Welcome to Oryx Learning. Today's lesson is on Unit 5, Functions, Lesson 8, Quadratic Functions. The outdoor observation deck of the Space Needle in Seattle, Washington is 520 feet above ground level. Using the graph below, approximately how far could you see from the observation deck? If you'd like to know the answer to this question, please follow along and we'll revisit it at the end. A quadratic function is a function in which the greatest power of the variable is 2. The parent function, before any transformations occur, is f of x equals x squared. Its graph is called a parabola, which is a U-shaped graph opening upward and downward. Some examples are shown below. To graph a quadratic function, follow the steps below. 1. Make a table of values. 2. Plot the ordered pairs. 3. Connect the points with a smooth curve. For example, here's our table with x values of -2 to 1. Substituting in -2, -1, 0, and 1 into the function f of x equals x squared, we get the y values 4, 1, 0, and 1. Plotting the ordered pairs, we would get a parabola that looks like the graph on the right. Select the type of function shown by the graph below. Is that function linear, quadratic, or neither? In order to be linear, it would have to create a straight line. We can see that the graph is not a straight line, so it is not a linear function. In order to be quadratic, it would have to form a parabola or a U-shaped graph. The function shown does not form a U-shaped graph, so it is not quadratic. Therefore, it is neither. Graph the points listed below. Is the graph linear, quadratic, or neither? Plotting the points 0, 8, 2, 2, 4, 0, 6, 2, and 8, 8, and connecting the dots with a smooth curve, we can see that that is indeed a U-shaped graph or a parabola. A parabola is the graph of a quadratic function. Complete the table and then graph the function. Y equals -3x squared minus 2. Substitute in a -2 for x in the equation to get -3 times -2 squared minus 2. This will result in -14. So that's the point -2, -14 on the graph. Substituting in a -1, we'll get -3 times -1 squared minus 2, or -5. This is the point -1, -5 on the graph. Substituting in a 0, I get -3 times 0 squared minus 2, which is just -2. So that is the ordered pair 0, -2. Substituting in a 1, we get -3 times 1 squared minus 2, which simplifies to -5. So that's the ordered pair 1, -5. And lastly, substituting in a 2, we get -3 times 2 squared minus 2, or -14. So that's the ordered pair 2, -14. As we can see, connecting them with a smooth curve forms a parabola. A paper airplane is thrown from a balcony 10 meters off the ground. The path of the airplane is modeled by the function y equals -0.2 t squared plus 10, where t is the time after the plane is thrown and y is the distance from the ground. Complete the table and graph the function, then determine how far off the ground the plane is after 5 seconds. Substituting in values for t from 0 to 7, we can see that we get 10, for the coordinate 0, 10. Substituting in a 1, we'll get the ordered pair 1, 9.8. Substituting in a 2, we get 2, 9.2. Substituting in a 3, we'll get 3, 8.2. Substituting in a 4, we'll get 4, 6.8. Substituting in a 5, we'll get 5, 5. Substituting in a 6, we get 6, 2.8. And substituting in a 7, we get 7, 0.2. Plotting those points, this is what the graph will look like. After 5 seconds, the plane is 5 meters off the ground, which is shown in the graph and in our table by the point 5, 5. Back to the Space Needle. If the outdoor observation deck of the Space Needle in Seattle, Washington is 520 feet or 160 meters above ground level, use the graph below. Approximately how far could you see from the observation deck? If we look at approximately where 520 feet would be from the y-axis, we can follow that down to estimate that you could see approximately 28 miles from the observation deck, which is about 45 kilometers. So remember, a quadratic function is a function in which the greatest power of the variable is 2. The parent function before any transformations occur is f of x equals x squared. Its graph is called a parabola, which is a U-shaped graph opening upward and downward. We can see these functions in a table and in a graph, as shown below. That is our lesson for today. Thank you for joining us, and I hope you enjoyed it.